Welcome to this deep dive. Today we're getting into something pretty specific. The technical specs for the EB65 and EB76 mandrel benders.
Yeah, we're looking right at the manufacturer's own data sheet here.
Exactly. Pulling straight from the source to, really unpack what these details tell us. Think of it like getting under the hood.
Mm-hmm.
Our mission, understand the capabilities, the automation involved, and why these specs actually matter. Maybe you're evaluating gear, designing parts, or just curious how complex metal bits get formed.
Right, because spec sheets, they can look a bit dry, can't they?
Oh.
Just lists of numbers, maybe some acronyms.
Definitely.
But they really do paint a picture of what a machine can actually do. We want to translate that tech speak into, well, real insights about power and precision.
Okay, let's dive in then. The sheet immediately calls these CNC automatic 3-axis mandrel benders, and it mentions Y and B servo positioning.
Straight away.
That tells you this isn't some simple hand-operated tool. So this combination, 3-axis CNC, Y and B servo control, what does that really unlock?
Well, it unlocks a huge amount of, let's say, intelligent control.
Mm-hmm.
CNC, computer numerical control. That means software is directing everything with incredible precision.
Okay.
Those 3 axes. Typically, that's your bend angle, then the tube feed, how far it moves along its length, that's the Y-axis.
Right, the link.
And then its rotation between bends, that's the B-axis.
Mm-hmm.
Adding servos to Y and B means those movements aren't just controlled, they're extremely accurate, repeatable.
So bending in 3D space, basically.
Exactly. Following a digital plan, precisely, time after time.
Okay, so that's the precise movement. But what about the bending action itself? The specs talk about an extended bending head capable of bending complex shapes and profiles. How does that physical part link up with the digital control we just discussed?
That's where the physical potential comes in. The extended head gives the machine more room, basically, more clearance,
right,
and the tooling capacity to handle tricky bends, maybe multiple bends close together or bends going off in different planes.
complex stuff.
Yeah. Combine that physical capability with the CNC precision, and suddenly you can make shapes that would be, well, incredibly hard, maybe impossible otherwise.
Manually, you mean?
Manually, or
Okay.
even with simpler machines, yeah.
Mm-hmm.
Think about modern furniture frames with those swooping curves, or maybe a high-performance car exhaust manifold needing exact geometry. That combination is how you produce those designs reliably.
And this is where the efficiency side kicks in, right? The automation and control features mentioned, things like automatic or manual bend sequencing,
Yes.
an interactive touch screen, and crucial bits like programmable material springback settings and programmable auto mandrel positioning.
That stuff speaks directly to the workflow and the quality you get out. Automatic sequencing means you load the tube, hit go, and it just runs the whole sequence of bends.
Minimal intervention.
Right. Huge boost for throughput. And features like programmable springback, those are absolute game changers for consistency.
Because materials bounce back a bit.
Exactly. Different metals, different thicknesses, they all spring back slightly after you bend them. The machine can be told exactly how much for each specific material and automatically compensate. So the final angle is spot on.
And the mandrel positioning.
That optimizes the support inside the tube during the bend. Prevents it from wrinkling or collapsing. Keeps the tube's shape intact.
Makes sense. It even mentions a programmable tailstock interference zone that monitors position and prevents collision.
Well, yeah, that's critical.
Yeah.
Safety, but also automation. On complex parts, things can get tight. There's a risk of machine parts, crashing into each other.
Right.
This system keeps an eye on potential clashes, so the machine can run faster, closer to its limits, safely, even unattended sometimes. It really highlights that these are designed for high automation once you've got them set up.
And handling the actual design data and operations, we see USB for unlimited program memory storage, tangent or centerline programming, even a handheld remote bending control.
All useful features. Unlimited storage means you save the recipe for every single part. Recall it instantly.
Convenient.
Tangent or centerline programming, that's just different ways to define the bend radius, gives you flexibility depending on your design software. And the remote, super handy for setup, for tooling changes, lets the operator jog the machine carefully while watching what's happening up close.
So let's step back. Looking at all these specifications together, what's the big picture here? What should we take away about these EB65 and EB76 machines?
I'd say these specs show highly sophisticated, precise, and automated bending systems. They're built to consistently make complex tube shapes with very little manual input after the initial setup.
Right.
They integrate features for accuracy servos, spring-back compensation for efficiency, like the auto-sequencing and program storage, and definitely for safety with that collision monitoring. This technology really geared for high-quality, repetitive manufacturing.
Yeah, understanding these specs really helps you grasp how modern automated bending works and why machines like this can tackle jobs that used to be, I don't know, more like craft work or just too costly and inconsistent for mass production.
Exactly. And that kind of leads to a final thought for you, the listener. Think about the manufacturing world. Before this level of precision and automation was readily available, what kinds of product designs, what efficiencies that seem normal now were actually really difficult or maybe even impossible back then, specifically because we couldn't reliably bend complex forms like this. Something to ponder.
Definitely food for thought. Thanks for joining us on this deep dive into the specs of automated bending.